Okay, so question number 5 asks, what is the configuration for sulfur? Okay, so I'll just quickly explain how one can find the electron configuration. So the first step is to draw out, well, not draw out, but to section off your periodic table into the different orbitals. So this is an example of what that would look like. So the two leftmost columns is the S block, and this green like rectangle from 5 to 10 is the P block, and the middle transition metals is the D block, and the last two rows, which are the lactanides and actinides, is the F block. So when we want to write out the electron configuration, we would first start off at hydrogen and then move left to right across the periodic table until we get to our desired element, which is the sulfur. So we would write the row number and then the block letter, and then show how many electrons would be in that orbital. So starting at hydrogen, we have 1s, then going across is 1s2, and then onto the next row with the lithium and beryllium, we have 2s2, and then going across to 2p, we have 2p6, and then onto the next row, which is 3s2, and then skip over to 3p, and then to get to sulfur, we just need to count up to it. So 1, 2, 3, 4. So this is the following electron configuration, and we can also write this in the shorthand way. And to do that, you just need to look at the noble gas that comes before sulfur, which is neon. So we just put that in square brackets. And then we just continue on naming the rest of the electron configuration normally. So neon 3s2, 3p4. Okay, so let's see what the junior tutor said. Neon 3s2, 3p4. Explanation. They went all out with the explanation to an element's electron configuration is a numeric representation of its electron orbitals. Electron orbitals are regions around an atom's nucleus where electrons are likely to be located. An electron configuration can tell a reader how many electron orbitals an atom has, as well as the number of electrons in each of its orbitals. So it shows the distribution of electrons of an atom in a molecule. Area where the electrons orbit is called an electron shell. As an atom or molecule gains electrons, they fill different orbital sets according to a specific order. Each set of orbitals contains an even number of electrons when full. The sets of orbitals are the s orbital, which can hold 2, the p orbital that can hold 6, the d orbital can hold 10 electrons, and the f orbital can hold 14. So when writing electron configuration, find the element's atomic number and locate it on the periodic table. Determine the atom's charge. Uncharged atoms will have exactly the number of electrons as represented by the atomic number. The electron configuration notation, so there clearly displays the number of electrons in an atom as well as the number of electrons in each orbital. So they should be written in sequence. Number of electrons written in the superscript to the orbital name. And the final electron configuration is a string of orbital names and superscripts. Fill in the orbitals according to the number of electrons in the atom. And they Show how when you write electron configuration, fill in the electron orbitals starting with the lowest energy, following the Aufbau principle, Pauli exclusion principle, and Hund's rule. And they got the correct answer. Yeah, so this solution is correct. They had a very in-depth and well-explained answer.